Morning, at least it is in Central Time US in Austin, Texas, where I am. But thanks for joining us today on this webinar, a DevOps Jumpstart for new .NET applications. And we're going to have a great time today. I'm going to try to be efficient with the time and not take the full hour. We'll have plenty of time to work in questions. And so let's jump right in. I am Jeffrey Palermo. And I'm the chief architect of ClearMeasure. We are a DevOps-centered software engineering company, and we're based in the U.S. And I'm here to present a DevOps Jumpstart for new .NET applications. And ultimately, the goal is to enable your team to move fast, build smart, and run your system with confidence. And my belief is that every system can be absolutely world-class and compete with the best of the best. You just have to be equipped with the right tools and methods. And I'm really excited. Just looking over the attendee list of this webinar, we have a fantastic crowd. And so let's just do logistics. There is a Q&A window in the Zoom software that you can submit questions. And there's also a chat, but if you put a question in the Q&A, I will do my best to work it in during the webinar and not call you out by name, but just work in the answer into the webinar content. But I'll make the commitment that I will not close out the webinar until every one of your questions have been answered if I wasn't able to work it in directly as I was on the particular topic. So go ahead and put those questions in the Q&A window. And I also have an assistant on the chat, Rain. Her name is Rain, and she'll be sending out some links and whatnot. If you have any questions, you can chat with her. And in addition, I'll be giving out my direct phone number at the end of this webinar, and I enjoy hearing from some of you and helping you out. So let's get right into it. And let me shrink myself a little bit so you can see better. So the agenda for today is these 6 things. Objective, the objective we're trying to accomplish in starting a new project, what challenges we have, how to achieve speed, how to achieve quality, and then share some of the results that we've gotten for other clients and talk about next steps. And there are so many software leaders on this particular webinar. We've got some chief architects, some VP of engineering, lead developers, and your teams need to be equipped properly so that they can shine. And probably the topic interests you because you're starting a new application of some sort and getting started. And it's really important to get started the right way, because there are decisions that if you start them off on the wrong foot, they'll just have so many consequences down the road. I have a free offer for you. I published my latest book in May, and the manuscript is done, and we have preview editions you can get printed copies if you want. But just for being on this webinar, I'd like to give you a free copy of .NET DevOps for Azure, and it's a 270-page book. And it'll be being published by A Press. Probably in the next couple months, it'll be finalized from a distribution perspective. We hope to be in the bookstore at Microsoft Ignite. And if you're going to Microsoft Ignite, look for me. Make sure to say hi. I'll be one of the official conference reporters at that conference. And if you just email me directly, or even if you ask Rain in the chat, ask for your digital copy of .NET DevOps for Azure, and we'll get that sent over. Another resource that you might like is the Azure DevOps podcast. And you can go to www.azure-devops-show, and you can see all of the various guests. Had so many fantastic guests, including Scott Hunter, who's the main program manager for the entire .NET platform at Microsoft. But let's get right into our content here, and let's talk about the objective that we're trying to accomplish. Okay, so we all want speed, and so we recognize that we don't have multiples of months to get our project out. Oftentimes, once a project is commissioned, the next question that's asked is, hey, when's it going to be out? Or when's the first release? And so we need to think about speed to launch. We need to think about this Jumpstart event where it only happens once in the project until we want to get into a regular iterative routine, but there is a one-time event for how we jumpstart things, and it sets the stage for the whole project. It's so important. And there's challenges in the software world for new .NET applications, and they come in all kinds of different complexities. Your particular application could have some really complex logic. Your particular application might be more simple, but it has high scale characteristics that it needs to satisfy. Or the data may be specifically sensitive. Certainly in the healthcare and finance world, there's some specific data considerations, or just the volume of data could be massive. And then the architecture could be complex. If you have to integrate multiples of systems just to get anything to work, then you may have a complex architecture that you're struggling with. And there's choices that you have to make. Now, in my writings and our private courses that we give our clients, I hate it when people give the answer, it depends. And so I try never to say it depends. I try to get concrete. But there's also so many technologies, you have to make choices around those, and there's a massive amount of confusion because there's way too many options, way too many forks in the road. Now, our industry gives us another challenge, and that is just the demographics that we're dealing with in our industry. And so you as a leader of your team, you're dealing with this. And this chart comes from the last Stack Overflow developer survey, and it's basically years of experience, years coding professionally. If you look at 0 to 5 years, that's over 50%. That's over half. Okay, it's 57.5% of everyone who is a developer right now has 5 or fewer years of experience, and almost a third, have 0 to 2. Now that's not because people with, who've hit the 20 mark and the people who hit the 30-year mark are leaving. It's because of the massive growth in recent years of the custom software development industry. And I'm right at the 22-year mark. So that's what, 3, 4, top 4.5 something percent. And I have no desire to get out of the industry. I don't think anybody else in my generation is either, but we just have this massive growth. So, we don't see this bell curve of distribution in the middle. We see a huge increase, huge growth over the last 8 years, according to this data here. And so that let me give you an analogy of a auto mechanic shop owner. Started a brand new mechanic shop, built a brand new building, great piece of property, said, only the best will do. I'm going to do this right. He goes to the dean of the local auto mechanic school and said, I want your top 7% of your next graduating class. I'm going to pay him what it takes. Only the best will do. Gets beautiful new equipment, tools, gets them shipped out to the shop. He ends up hiring that top 7% of fresh, smart, passionate mechanics. Really, they know cars, and brought them out to the shop, and they're in front of this beautiful new building, and the owner, kind of really proud of himself, says, all right, team, let's get ready for opening day. The customers are going to start coming next week. And he walks away kind of smiling ear to ear, and the team, top of their class at the auto mechanic school, kind of looked at each other, and they were really, really nervous because they had never been taught how to set up their own shop. They had been taught in a shop that was professionally set up for them. And we have that dynamic here in the industry. There's so many coding schools now popping up. There, even the computer science curriculums at the universities, but actually setting up the equivalent of our shop, setting up our factory floor, whatever analogy you want to grab, that's not in the common curriculum. And so we as leaders who've kind of learned it through experience, we're in charge of doing that for our teams and setting them up for productivity. And so when we're jumpstarting this new .NET project, we have to think about these things. All right, the conventional view of DevOps is on the left, and that's the glyph straight from Wikipedia with all the various stages. And I absolutely hate it. I disagree with it because it violates the remerging of Dev and Ops, and you get handoffs between Dev and Ops and surrounding it. Whereas really, Scrum tried to get everybody to have a single cross-functional team. And then DevOps came and said, okay, Dev and Ops is still different in the industry. We need to stop that. If you build it, you run it. And if you run it, you need to be able to build it. And so we need to really have that cross-functional team concept and have the process just spin faster and faster and shorter cycle times. So I prefer the model on the right side, where the hub is the automated DevOps pipeline. It's that key infrastructure that you just need in order to be able to plan, code, integrate, package, release, operate, and learn. Okay, but there's some other things that we need to fill in the process with, other organizational capabilities that we need to fill in the gaps with. And so we have this model, and I tend to call it the onion DevOps architecture, but this model that enables DevOps-centered software engineering. And so each of these layers, you have to have a sound strategy to it: best practices, defect removal, team workflow, architecture blueprints, and cloud operations. Each of these layers have to have a sound strategy, be executed with discipline, and have objective measures. It's not enough to say that you've equipped your team with defect removal, for example. By the way, your strategy is the selection of defect detection methods. So we have research from Capers-Jones who spells out that the combination of defect detection methods that are proven to achieve high 90% of defect removal. But having a strategy in each one of these areas takes the guesswork out of the process for our team. Now let's zoom in and look at that automated DevOps pipeline. So this is a highly shrunken technical blueprint for the structure and flow of a pipeline implemented with Azure DevOps services and also Octopus Deploy with continuous integration build, a 3-tier deployment pipeline. By the way, you'll never have fewer than 3 environments, even for simple applications or microservices. And we have some other webinars that dive deep into these details, and we have some Octopus Deploy specific webinars. Please reach out for some, if you need more information on how to set up the infrastructure just specifically for DevOps automation. We do a ton of that. But that is just one piece, but that's the starting piece. And so if you would like the complete poster, then reach out, and I believe Rain is going to post a link in the chat as well. This is just the top 1/3 of the poster. It's a high resolution, 2 foot by 3 foot blueprint for the different layers of a DevOps pipeline. And we've done a webinar on the 7 key elements of a successful automated DevOps environment. And so this is the infrastructure that you need to get started with, but we also need to talk about how to get work into this even from the beginning. You are starting a new project, okay? So let's talk about process a little bit. Here's the 12 key steps in any process. Now, most people have more, but you really can't have fewer than these 12. And notice that the developer actually writing code is step number 5. We have 4 steps even before we get to writing code. And so obviously if we don't have any code, we don't have any start of an automated DevOps pipeline that operates on that code. And so there's 4 things that need to happen before we can write code: concept definition, user experience design, technical design, acceptance criteria, and test design. And if we don't do those and we say, hey, developer, do this feature. Well, the developer sits there thinking about, okay, what kind of code am I going to do? And then the developer is trying to make sure that he understands the concept and figure out the user experience design, make any technical decisions on the fly or what NuGet packages, and then figure out what it means to be done. All right. So we need to equip our team with a complete process right from the get-go. Otherwise, it's going to be firefighting from day one. Okay. And so you need to take these steps and put it on a Kanban board. Make these the columns of your board. I don't even care if you're using Azure boards or something else, but use this. And so conceptual definition is, what the heck is this? What's our goal? What's the objectives? Then once we think we understand what it is, that could just be a paragraph. Then we drag the card over to the user experience design, and that is wireframes. Let's sketch out how a user is going to actually use this. Is it a 3-step wizard process? Is it just a simple CRUD edit save type of thing? What is it? How is the user going to actually experience that this feature exists? And then technical design is, what libraries are we going to use? What technical patterns are we going to use? Updating the architecture blueprints, and we'll get to that in a second, but making any technical decision that needs to be made, data models, things like that. And then acceptance criteria and test design. If you're using Scrum, this is the perfect implementation of Scrum's acceptance criteria is a bulleted test scenario. It's just a list of what to do in order to test this. And if you know the user experience design, you should be able to imagine what you would do in order to validate that the new feature does the right thing. And armed with that, the developer can implement the right thing, but also automate the acceptance criteria into full system tests. And if it's a web front end, it's easy because you use Selenium and you deploy, and then you run those Selenium tests and actually exercise the full system. And then we go forward. But I wanted to touch on those things ahead of coding because it's so important that you get the right process in from the get-go. And we see so many teams jump in and they might have 1 or 2 columns ahead of actually defining the code, or they have somebody writing code even before they have architectural blueprints and the tail's wagging the dog. And that is the perfect recipe to get a project off track right from the beginning, is to have no strategy and no process. Or look at this diagram. This is the flow of a factory floor. And so how can you start manufacturing anything if you don't even have the flow of a factory floor? So that's super important. And you as the leader, I imagine it's on you to put this kind of structure together. Okay, so let's get back to the model. Let's go through the order that you need to execute when you're starting up a new project. Okay, so we're not going to go in order from the middle outward. Now, if you are in progress and you're just implementing DevOps for the first time and trying to get a good process from your team, and you've been going on a project for some time, then I would advocate starting from the middle outward. But if you're starting a brand new application and you have no software whatsoever, there's actually a different order that is the optimal implementation. And so we're going to start with team workflow. Most software project tracking tools use swim lanes or columns that are essentially statuses to move a piece of work through the process. But we find that the process is less granular than what actually happens in real life or what needs to happen. And so if the motion in the team doesn't reflect in the work tracking tool, then you'll have bottlenecks that happen. They'll remain hidden and they'll sap your schedule. And so your complete workflow, it'll shed light on every bottleneck source, and it'll enable your team to have a constant and predictable flow that can be tuned and measured. And so here's the Kanban board that has essentially the minimum number of columns that you can really cope with from a development perspective. And notice those 4 extra columns ahead of the development column. And in the technical design, that's often a place where it's good to take a feature and decompose it into independently implementable user stories or product backlog items, whatever you like to call them. And then in the functional validation, that requires a deployment to an actual environment and run it through its paces. And then user experience validation is typically some manual testing by some customer group, and of course they operate at the feature level, whereas maybe the development team operate at the story level. But make sure that you have plenty of columns in your work tracking board, and every column needs to have a definition of done. Every column needs to have a quality control checkpoint validating the work that came from the column preceding it, and every column needs to have a role that is assigned to it. So if a particular column is just bottlenecking and all the work seems to be piling up in that column, we know that a particular role needs to be scaled so that we can have more capacity on a particular column, so that we can normalize the flow of work through the process. The next layer to implement, the next thing right off the bat, you got your process. Now we need to think from day one, how am I going to detect and remove defects? because defects are going to happen. There's research for the Capers-Jones is compiled on defect potentials based on a type of software. It's a way for you to guess and estimate how many defects your team is likely to generate. And there's research that shows on average that far less than half of defects overall are defects in the code. For instance, requirements, and for every 5 defects, 2.23, which is not quite 50%, of every 5 defects comes from requirements or design, even before code was written. Code accounts for 1.75 out of 5 defects. And by the way, bad fixes account for almost 10% of defects. It's a bad fix. And by the way, if you're interested in reading more of the source research, you can look up Capers-Jones. He actually summarized in a 2012 paper called Software Defect Origins and Removal Methods. That's Software Defect Origins and Removal Methods, and you can search for that. But based on the type of software you have, you need to strategically select the defect detection methods that are shown in the industry to get us to the high 90s. And those, there's 3. There's the magic 3 that you need to at a minimum, and that is static analysis, testing, and inspections. And the perfect place to put a formal inspection is in your pull request process. If you put a checklist in your pull request process where the person clicking approve has to say, I have gone through this checklist, well, guess what? You've got a formal inspection process. Static analysis can go right in your continuous integration build. And then testing, you need 3 layers of automated testing. And then you also need to have actual formal manual testing. And if you're using Azure DevOps services, you can have your business partners or product managers or whoever is going to be testing the software actually record their testing sessions with an easy browser plugin that they can just hit a button and it'll actually record their entire screen process, so that they don't have to remember what they did whenever they encounter a problem or a request for something that changed. So static analysis and 2 of the 3 types of automated testing need to go in the continuous integration process. Unit testing and component level integration testing. Component level integration testing has got to be in your continuous integration build, and that covers things like going between your runtime.NET process and your SQL Server database. You need to make sure those are talking. Well, because of that, you need to have your continuous integration build set up your database and create the schema from scratch, therefore proving that you actually know what that version of the schema actually is. Okay, so those are really important right from the get-go, even before you have any code. You need to put that in place. Next, we need to look at the pull request flow. And this is all around the theme of defect removal. This is checking to make sure that we don't have problems. So there's a loop from specifying the test scenarios ahead of code, the acceptance criteria, just a simple bulleted list of do this, log in, go to this screen, check this, type in this, hit this button, things like that. And so we change the code. Engineers need to execute a private build process, do a git commit push, CI build happens. We do our first line deployment to our automated testing environment. We like to call that the TDD environment, the test-driven development environment. It's really important. No humans are allowed on this environment because every build is going to rip the environment apart, reprovision it, redeploy, and then after those acceptance tests run on a fully deployed environment, then we can create our pull request. And then somebody on the team, whoever's designated, can do the formal inspection checklist for the pull request and hit accept, and now our changes are over in master. So of course, this does assume that we're using some type of branch-based development process. And I think the most common type of branch-based process that's emerging is ironically called trunk-based development. So if you just look up trunk-based development, it's a series of very short-lived feature branches where no development is actually done on the trunk or the master, but all development is done on a branch, but they're really small, short-lived branches. All right, after defect removal, then we need to look at best practices. Now, there are effectively so many best practices that it is logistically impossible to use all of them on a given project. So if there's so many best practices where you can't use them all, then you need to select which best practices you're going to use. So when someone says, of course we comply with best practices while doing this project, that's not enough. You got to equip your team and even have a discussion. What practices are appropriate for this particular project? One example, best practice commonly selected is buy versus build. And in research, it's called using stable, reusable components. And that's great. Perfect. But oftentimes an individual developer will just go and grab a NuGet package and none of the rest of the team knows that it was brought in, or maybe the lead engineer or the development manager doesn't know that we just executed another buy versus build, even if the buying was free because it was an open source NuGet package, that we had just executed another buy versus build decision. And so make sure that those are explicit decisions and that you have some type of expectations for communication in your team. But using the available commercial and open source reusable things in NuGet, absolutely fantastic practice to use. All right, let's go over the next part beyond building to make sure that you have set up in order to jumpstart your .NET project in a good fashion. And this covers these 3 columns on your Kanban board, from test design, development, and functional validation. So we're going to do some coding, a continuous integration build, a deployment, and then running full system tests. Okay. Now, this requires us to have automated deployments set up from day one. Now, these are the 3 types of environments. We want to make sure that we are not doing anything in production for the first time. That means that our environment configurations need to be the same from TDD to UAT to production. By the way, everybody knows production environment. UAT is a manual test environment. That's a second environment type. The third environment type is that TDD environment where it's no humans allowed. It's only for test automation. And we do the most there. We're going to completely provision environments from scratch. We're going to save data in UAT and production, but we're going to throw away and recreate all test data in TDD. All right. And you can have more than one of each type of environment, and most of our clients do. Just like if you deploy your software once for each customer, then you have multiple production environments. But there are 3 environment types. If you want to have a security or a penetration testing environment, well, that's another instance of the test-driven development environment. Whatever automated validation or automated tests you can run against a fully deployed system, that is an instance of the automation environment, the TDD environment. And UAT, the manual test environment, common names for those are dev, test, QA, stage, UAT, integration. There's all kinds of environments, but they're all manual test environments. Okay. Now, I want to hone in on the full system testing that it's good to start with right off the bat. And so we're going to zoom in here into one of the Azure DevOps Services screens. And this is an actual test run after deploying a system and then running some full system automated tests. And so we can see that there are 6 tests, and we've actually configured attachments. It's real easy with NUnit or XUnit to have Selenium take a screenshot of the browser window and just save that file, and then the tool will keep all of the attachments. So let's zoom in a little bit on what that is. And we can see that we've taken a screenshot. This right here is a screenshot of the inside of a browser window where we have list and add new as a simple navigation. This is a very small screen where our test is typing in text boxes and hitting a button and then recording a screenshot of everything that it's doing. Because sometimes when those tests fail, it's good to see, hey, what did the screen look like when it failed, so that you don't have to take the time to put the system back in the state, reproduce exactly. But if you can see an error message or whatnot, it can help you. And so since disk space is super cheap, it's a really good idea for full system testing to configure screenshots every step of the way as that test suite grows. All right, so the next layer of capability to think about when you're jumpstarting the project is architectural blueprints. And we like the 4+1 view model of software architecture. It was written about by Philippe Khrushchev in 1995, and at the time he was at Rational Software Corporation. You can Google for that, but the title is Architectural Blueprints the 4+1 view model of software architecture. Now, coming from 1995, that was right in the midst of when what would become Agile was being thought about, how to go away from waterfall and how to create iterative processes. And so to this day, this is still the best model for iterative emergent architecture, where from day one, you think, okay, I have an overall vague architectural vision for this, but now I need to pull way back and I need to think about what is the architecture that we're going to launch with? What is the architecture for my minimum viable release that the customer is going to use? Then you pull back even further and say, okay, what is my minimum viable testing release? In other words, the architecture for the system, the first time I can tell people in my own organization, hey, there is a single feature that you can check out. And then you look at the 4 different layers, which the 4 different layers are physical. In the 90s, it was called physical, but I think of it as the runtime layer. Is going to run cloud, on-premise, VMs, serverless. That's the runtime layer. Logical, which is dependencies between modules. The third layer is process, which is how data flows through the different components of the software. And then the 4th layer is development, which is what is the structure of the overall development environment that allows a person or a team to actually develop and change this. So think of that as your DevOps environment. The structure of your source control, the tools, the setup of your workstation, the sequence of your environments, all that stuff is your development environment. Those are the 4 minimum layers that you need to define for your architecture blueprints. And so you have immediately you have 3 sets or 3 revisions of your architecture to kind of proves that this is iterative and emergent. You have your more higher level long-term vision. Then you have the architecture for what you think your minimum viable commercial product is going to be. And then you have your absolutely initial, what the architecture needs to be for you to have anyone in your organization even test the first feature. Okay. And that guides the team and shows them that we don't need to have every architectural element for the long term or even for the minimum viable product in place before we can write the code for one feature. And it gets them in the mindset that yes, everything we do is going to be iterative and everything is going to be emergent. And it gives you an architecture framework and routine to support that. Okay, so the next is thinking about how you're going to run this software, which is the runtime layer of your architecture. But how are we going to run it? You got lots of options. You can run it on-premise on physical servers if you still have some of those, or hosted VMs, or Azure VMs, or you can run it in containers, or you can run it completely serverless. And Azure App Services is an example of that. Azure Functions, Azure SQL, completely serverless with no operating system to maintain. Now, the spectrum with a lot of .NET applications, you can choose any of these, but the ones on the left, you have more control and more responsibility. On the right, you have less control but less responsibility. On the left, there's more to maintain. On the right, there's less to maintain. And so from that perspective, you may choose the strategy of, hey, let's go as far to the right as we possibly can. I want as little to maintain as possible. And it's interesting that containers are getting a whole bunch of attention. And I do believe that containers are going to revolutionize the software industry and give us a way to essentially eliminate running on a full operating system on a VM. But if you're jumpstarting a new .NET application, you don't have to stop at any particular place. When you're starting something new, you have the opportunity to grab the state of the art, and that is platform as a service. That is, hey, you don't even need to think about how to run containers. You can go straight to platform as a service and say, hey, just run my code. And then you can evaluate your dependencies to see if that prevents you from doing that. Now, one thing to think about, and this is in your architecture as well, if you need to install a custom font, for instance, if you need your screen to have a custom barcode font in order to produce barcodes for scanning, if your software is going to be used in a warehouse or somewhere where you need a USB or a serial scanner, then, well, guess what? It already rules out Azure App Services because you can't install fonts. And so you're going to have to pull back to Azure Container Service or Kubernetes Service because you need just a little bit more control so that you can install a custom font so that your application can paint those barcodes. But those are the architectural things that you need to think about that will impact your runtime decision. All right, next is how you package up your release candidates. And so let's say that your minimum viable product includes ASP.NET website, an offline job of some sort, and then a SQL database. Okay, well, you have those three logical components on the left, and they may translate into a single instance, or it may translate into running the offline job as a scaled out set of Azure functions, or a scaled out high capacity app service. But you also need your acceptance tests. And so you need to call that out because it is a versioned and deployable part of your application. It's important that you map each of these logical components into a runtime type. You can run them on a VM inside IIS and inside a Windows service, but if you're going to go platform as a service, you just need to pick which one, okay? And with the SQL database in Azure SQL, you can run it as a managed instance. You can run Elastic Pool. There's a few different types of SQL database that you can use. But you need to think about how you are going to deploy it because you have 3 deployable components in your application, and they each need to be packaged up and versioned. And these 4 components overall, when you include the test, become your release candidate. All 4 will have the same version number, and they will be your release candidate. All right, now that you've thought about how you're going to run it, what the architecture needs to be, you can start actually doing a little bit of skeleton coding. And see how far we've come. So many development teams have a developer start slinging code, and then the code that is written ends up dictating accidentally some of the architecture. So now that we made these decisions, we can start writing some code. Now we need to think about how to lay down the Git repository. What is the structure of the version control system? And there are some rules that we need to comply with, or else our experience is going to be less than ideal very, very quickly. So all of the tools in the ecosystem tend to adhere to a set of rules and a set of conventions. So let's start at the top of this diagram. And by the way, this diagram and some of these other concepts are in my book, .NET DevOps for Azure. So make sure to go ahead and get a copy of the book. I'll start at the top with the software system. Let's say that overall your software system has 3 different applications. So, a software system can have many applications, or a software system can just be a single application. If you are using microservices, then you've already decided that each of the decomposition of the software system is going to be an independent application and be able to be versioned, developed, and deployed on an independent schedule and be autonomous from the others and interact based on concrete, architectural APIs of some sort. So a software system is segmented into many versioned software applications. Here's the rub that we see missed by so many teams. Every versioned software application needs to be in its own Git repository. And a Git repository needs to have only one versioned software application. In the .NET world, that is the Visual Studio solution. So concretely, a Git repository needs to have a single Visual Studio solution. Now, we look at so many legacy software applications that have had a long history, and yes, every one of these rules is broken and life is already hard and people want to figure out how to rewrite it. But you are jumpstarting a brand new .NET application. You have a chance to do it right from the get-go. So make sure that each of your Git repositories has only one Visual Studio solution in it, which represents one version software application. Every project in that Visual Studio solution is part of that application and is going to have the same version number and is going to be deployed at the same time. If you find that you want one of the projects to have a different version number or to be deployed at a different cadence than one of the other projects, then it might be a sign that architecturally you have actually two applications, okay? If you break any of these rules here, then all of the tools in the DevOps ecosystem are going to fight you, and you are going to have to write so much PowerShell script in order to transform the model back to what they expect. Okay, so let's keep going. You have one Git repository, and it needs to be built by one continuous integration build. All of the tools, the build servers that are out there, they were designed so that you had a build that operated on whatever was in a Git repository. And there is one version number per build, and everything in that Git repository is going to get that same version number. Okay, so make sure that you have one continuous integration build for each Git repository, which will have exactly one Visual Studio solution, which contains everything that is a part of one versioned software application. Okay. Everything downstream from the organization of your Git repositories is going to be made simpler when you adhere to these rules. If you have multiple applications in your software system, let's say you have three, whether they're microservices that, or whether you just want to take the software system and chunk it up into 2 or 3 pieces. Let's say you have 3 Git repositories. Each one of them has one Visual Studio solution, and each one has one continuous integration build. So you would have 3 continuous integration builds on your build server. Each of those builds needs to package up the set of release candidates. And of course, you could have multiple things that need to be deployed in a Visual Studio solution. So you'll have multiple NuGet packages, but they'll all have the same name and they'll all have the same version number because they are all the same application. It's just one might be, oh, this is the package to install the web application. This is the package for the offline job. This is the package for the SQL database. If you're inheriting a SQL Server database from the past, you might have to declare that SQL Server database as an application in and of itself and give it its own repository, give it its own build, give it its own packaging, give it its own deployment, and then package up the schema as a NuGet package so that the other applications can actually consume it as a NuGet package and then use and leverage a schema that they do not own. That is a trick to handle legacy software databases while at the same time moving to more published API and published SDK patterns instead of just giving an application a connection string and having unstated implicit dependencies on some other application schema. So if the dependencies are coming in via NuGet, then that dependency is pretty explicit. Okay, let's keep moving. So we'll talk about cloud operations next. And by the way, this is the same even if you're operating it in your own data center, but operating the software is how we deliver value to our users. And they're going to have issues from time to time. If we rely on a user to report an issue, then we are only capturing a subset of the available information. We should see proactively that a user was struggling, much less received an error. Okay. Secondarily, we should know if our application or applications in the system are doing the right thing. We should know how busy they are. We should know what cycles of usage behavior and what features are used the most and the least. Many teams have some logs, but not enough. And a lot of times an admin has to log into a production server just to look through them. There's no aggregation, no performance timings. The goal is to make the software system completely observable, to know what it's doing. And so bake that in from day one, all right? You're gonna do a deployment. By the way, when we help our clients jumpstart a new project, we get a build and a first deployment going by day number 2. That is in actual environments, just a skeleton deployment. And so by day number 2, we can get skeleton telemetry flowing because guess what? We have something that's running. And so we springboard from the mapping to the runtime architecture that we can see on the screen. And then we make sure that each one of these is connected to a application performance monitor. In Azure, that is application insights, and VMs and other legacy logs can be configured to flow into log analytics. But given that you're creating a new application from scratch, you want to take application insights and integrate it right into those components from day one, and you get powerful telemetry, aggregation, and querying capabilities. Now, let's talk about telemetry, because that's just the tooling of putting it all in the same place. So telemetry, there are 3 types. And I find that most people are familiar with logs. Those are just, flat log files with whatever statement you decided to put into it. And you can grep, you can use Microsoft's log parser to execute some queries against it. You can do a find next instance of the word exception. But everybody knows logs. But there's 2 more that need to be in there from the get-go. And one is metrics and the other is events. You've probably implemented a star schema or a data warehouse for some department of your company, and the structure of it has been dimensions and facts. Dimensions and facts are just like events and metrics. This has enabled your different departments that use the data warehouse to use tools like Excel and Tableau and Power BI to query against that data and get answers out of that volume of information. So as the leader of the team, you need to do this for yourself. Your software, once it's deployed to an environment, and even the DevOps pipeline itself, is kicking off lots of information all the time. It needs to go into your data warehouse, and your data warehouse needs to be configured with the right structure of data so that you can use the same business intelligence tools that your other partners in the business use in order to pull out information and reports and graphs and charts and KPIs. And so the building blocks of that, besides just your logs, are metrics and events. Events are just like dimensions. They are named things that the software does. And so login success might be an event. Think of it as a big old enumeration. Login success, login failure, login attempt, work order submitted. I mean, and even navigating to a screen could be an event. And then the event has extra pieces of information like what user did it, what time it was. And so metrics are numbers. They're always numbers, and they need to be compatible with aggregation methods like average, sum, min, max. And that way you can group by events, and then you can select some of the metrics. Sorry, you can select average, metrics, sum, min, max. And that way you're setting up your data warehouse for your actual application. Now, App Insights gives you a lot of stuff for free, right? I mean, within 10 minutes, you're getting what you see on the screen. And queries over to a database, you get it for free, and you can query, it's really instructive to be able to say, okay, I clicked on a button, select count of SQL dependency calls, and know how many calls to a database is happening just by clicking on a single button. All right. Now, in Application Insights, there's also a way for your DevOps pipeline to create a deployment marker, and that's highlighted here on the screen. And that essentially is sending to Application Insights, sending to our operations data warehouse when a deployment happened. Now, if my numbers and performance and different things start going sideways, it would be very instructive to know, oh, I just deployed version such and such, versus we haven't done a deployment in a couple of days. I don't know why these metrics are going sideways. If we click on that in Application Insights, then we get a wealth of information about exactly what version it was, where it was deployed, and we can even click over to Azure DevOps Services to see that. So that's all a part of operations. You need to know what your application is doing, or all of them in the entire system. So this is our model for equipping a team to be world-class, to move fast, build smart, run with confidence. And each of these layers are important to setting up a team for success. And I think I've worked in all of the questions, but there's one comment that one of you said that you face many dependency errors, and yeah, and that happens a lot. We need to know when that's happening and be able to quantify it, and so it's really important for operations. Now, we've had a tremendous impact for so many of our customers, and we really enjoy helping our. You can go to our website for some of the success stories, but there's one particular one that I'd like to share. Just a little bit, like the first few seconds of, and then you can go on our website and look at the rest of it. And that is on the next slide. And I'll go ahead and click here.
Azure was with us before we launched. From the time we initiated a project with them to launch was 4 months. And it was a rapid evolution of idea to conception to reality, and they were a critical part of that. Marlette was founded 5.5 years ago to provide.
And that goes on. It's a pretty long case study video, but I invite you to go to our website and check it out. That's you can go to bit.ly/project Jumpstart story to watch that. And whether it's a new application or a startup company or any event where you are starting a new project and you cannot afford for it to go sideways, we're here for you. There's a lot of people that come and say, hey, you're starting a new project. Why don't you outsource development to us? We do this and that. We don't like that. We want you to do the project, and we want to equip you to do it well. And so we're actually competing against the outsourcers, and we want to make sure that you have the right architecture, you have the right environment, you have the right tools, you have the right process, and you equip your team, and you have the right people. And if you need help, we can even help we've done this before, help interview. Most of our clients already have a great staff, passionate experts in your business, but you're starting this new project, and something about it, you need to do some more preparation. So we love helping our clients get off to the races so that your team can shine and really execute this project well. All right. And so let's go past this. And so one of the easy ways to get some help is to have us do some architect level advisement or consulting. And if you'd like a second pair of eyes on the organization, environment, or processes, we're happy to help there. And again, we want you to be self-sufficient. We act as your guide. And if you're on this webinar, that means you're starting a new project and things need to go well, and there's something you're not quite certain about, just give us a call. And worst case scenario, we'll point you in the right direction. Best case scenario, we'll be able to concretely fill in that gap for you in a quick period of time. So I'm going to put up my contact information on the screen. Before that, what to do next? And I've got a question I'm going to come back to in just a second. What to do next? Get the book. This book has so much information about how to put together an effective DevOps environment for a team. And it has a complete pit of success configuration where it doesn't say it depends. It says do it this way. And you can go to bit.ly/.net DevOps book to be able to order a print book of that, along with the free ebook version that we just gave you today. And so there's my contact information. I'll leave that up while I answer this question. I was able to work in the other ones during the content, but I faced many dependency errors, and most dependency errors are of API calls. Any suggestions regarding this? Yeah, two things. One is from an operations perspective, you need to wrap all of those calls with logging that, hey, you're starting the call, what the timings are, you completed the call, and how long it took. When there's an error, what is happening. Now, let's talk about how to handle those errors, which is actually another really important part. There are so many people implementing RESTful calls, that is over HTTP or HTTPS they're making calls to another system. And that's great. And that's great for integrating systems. However, when that is done, if you control both sides of the wire, you have more options. You don't necessarily have to have a particular service only provide an HTTPS API. The service could also provide a more native API, like a C# API. And that is super powerful because that offers the client applications the opportunity to not only call out in a synchronous fashion over to the service, but it also allows the service to be able to run code in process with the consuming client. And it allows the service to actually have some control over error management, caching, throughput, chattiness, and if there needs to be degraded functionality. If a service goes, if the service goes offline, then the service, the code that's running from the service in process with the client can do something intelligent. So, but from a minimum, you want to absolutely log all of that to application insights when those exceptions occur so that you can track that, put a line graph together, and then analyze it and find a remediation. But with the increasing amount of integration that we are doing just across the industry, it's super important that we know if an API call failed and what that failure was so that we can have it be reported and then work with our team to analyze it and find the root cause and eliminate it. So, that's a great question. And I know that's a widespread issue. And without properly instrumenting those calls, we don't have enough raw data to pull out information from our, air quotes, data warehouse for our particular system. All right, well, this has been a pleasure, and thank you so much for all of your time. We're going to go ahead and close it out here, and I'll leave this slide up for a little bit. And I love taking phone calls. You can find me on Twitter at Jeffrey Palermo. And let me know if you are going to the Microsoft Ignite conference. I'll be there, and I'm actually one of the, I'll be filling a conference reporter slot as a Microsoft community reporter. So you see me walking around with a camera crew. If you see that, say hi. And I hope everybody has a great day.